So, hi everybody. Yeah, welcome to my presentation. And I'm really happy about this, that I can be here. It's an exciting experience. So, today I want to watch out for pure functions in code where I wouldn't expect them so much. It will be a usual application sample that I want to go through with you. I think this is an application that, in the style that we write every day, so I think you will be easy to follow me. Currently, I work at Allegro as a backend software engineer. We do our services in Scala, and we take care a lot about functional style. And this was not always like this, because 20 years ago, I started my professional career. And I did object-oriented programming. So functional programming was at the far horizon for me at this time, and I thought that only people with a PhD are able to do this. Over the time, I noticed that I started to separate out non-trivial algorithms into separated places. And I did this because I wanted to test them better. And better testing means for me that I can test it more systematically, more easily. And maybe I did somehow I did functional programming at this time, but I wasn't sure. So a few years ago, I got the opportunity to dive into this topic deeper, and I want to share my experiences, my thoughts on this topic with you. So very often when it comes to functional programming, we see a definition like it's programming without side effects. But this definition never convinced me. It didn't tell me anything what functional programming is. It didn't. It just says what it's not. Really, I struggled with this, and I had problems with examples to get in. I hope I can close this gap today. And the one who provided me into the functional programming was in fact Professor Eric Meyer, a professor of computer science, who said that functional programming is programming with mathematical functions. And if we go back to school in a coordinate system, I draw a mathematical function here, and the property is that for each value on the x-axis, there's exactly one value on the y-axis associated with this function. If we look at such a thing, this is not a mathematical function, because here for each value on the x-axis, there are different values on the y-axis. So how relate these mathematical functions to code? We can express them, for example, with a method. I will show you all my examples in Scala today, but don't be afraid, it won't be cryptical stuff. So here with def, I declare a method. It's called twice. It takes an argument x of type int, and it returns a result of type int by doubling the value of x. This could be perfectly drawn as a function in the coordinate system that I showed before. Let's have a look at this function. It's another method, find by ID. It takes an argument, an ID, and it returns a result, data. And if you ask the compiler, is this a function? The compiler will tell you, yes, of course, it's a function, because it takes an argument and returns a result. So perfectly, it's a function. But something is different about this function, because probably this function sits on the repository. And now the question is, giving the same argument, the same ID into this function, calling it with the same ID, will it return always the same result, the same data? And of course not. If it sits on a repository and there's a database behind it, the record may change in the meanwhile, since the last call. Or maybe the record is even gone because someone removed it in the meanwhile. The signature of this method doesn't express this even, that maybe there's no data at all for this ID. There's another issue. This method may never return. Once in my professional career, I had this case that sometimes a query to an Oracle database did not return at all. You don't see it here in this signature. So if I come back to the first function twice, this is a mathematical function, because here the result only depends on the given arguments, on nothing more. There are no surprises here. And from now on, I will call these mathematical functions pure functions. And these pure functions are predictable, because you see everything what you can expect in the method signature. You can call them repeatedly. Giving the same inputs, you will obtain the same outputs. This comes in also handy if you want to cache the results. Next, you can call them in any order. In the moment that you have all the arguments at hand, you can just call them. You can call them in parallel, because they do not depend on other things than only the input arguments. And the third thing is they are safe to refactoring. If you compose bigger pure functions out of smaller pure functions, you can move your code around, you can replace values by expressions, or you can inline values, you can extract values, not changing anything in the output of your program. And this is the great advantage of pure functions. So if it comes to I/O is never pure by definition, and it won't be. You can handle it somehow in a functional way, but the nature of it is that it's not a mathematical function. So for me, functional programming is not so much about the side effects. It's much more about separating off the pure functions from the non-pure functions. And in our case here, in our sample application, we will separate I/O off from logic, from which can be expressed in pure functions. So let's jump in. My sample domain is ordering food via the internet. So we have restaurants, and these restaurants hang out their opening hours in local time. A restaurant is located somewhere on the world, and users can order food via the internet. And before ordering something, they would check if the restaurant is open, if someone works there. So we start to implement the first endpoint for checking if a restaurant is open. So we declare a method, is restaurant open? It takes a restaurant ID and returns a Boolean, and I think everyone already knows that this is not a pure function. This is a mix of, there will be some I/O inside, and there's also, of course, there's some logic inside this, which could be maybe expressed as pure functions. I will annotate this here on the right side. What is the character of each method? Okay, we start to get out the restaurant data from the database. This is, of course, I/O. This method returns an option, Scala option. It's the counterpart of Java's optional, or maybe the waiver option. So if the option is empty, there's no restaurant in the database, then of course we will return false, because a restaurant that doesn't exist cannot be opened. But if there's a restaurant, we go on. I pass in a lambda here that does something with the restaurant. And next is, I calculate the current day of the week by calling a utility method. I pass in the time zone of the restaurant. And now the question is, passing in the same time zone in every call, with this function return the same result? And of course not, because if I call it today, it will return Tuesday. Tomorrow it will return Wednesday. So obviously, this is not a pure function. There's I/O in it because it relies on the current computer clock, on the current time of the computer clock. But there's also some logic inside. It's not like this that I just return the time zone. Next, we use this day of week. We go to the database again, load opening hours, and filter the records of opening hours for the restaurant in the database. This is clearly I/O. Another method, we calculate the current local time in the time zone of the restaurant. This is the same case like current day of week. It relies on the computer clock. So it's I/O and there's some logic inside. And now hours returns an option. So if there are no opening hours, or if there's no opening hours in this day, restaurant cannot be opened. But if there is, we call a method if the current time is enclosed by these opening hours. And let's have a look at this. Let's imagine that we have a class hours that has two fields, from and to, and the method encloses checks if the given time is between them. Now the question is, does encloses return the same result when passing in the same local time every time I call it? And here's a small detail I need to mention. I declared this class as a case class. This is in Scala the keyword for making it immutable. So it's the counterpart of a Java record or of a Kotlin data class. And having this, having an instance of hours and calling repeatedly encloses, giving the same local time, it will return always the same result. So we found a pure function in the first place in our code. Yeah, so that's nice. And this is how it looks like. On the right side here in these annotations, you can see my definition of spaghetti code. This spaghetti code is a big mix of I/O entangled with pure functions, and this is hard to maintain, hard to reason about. And that's why I want to refactor the code to make it a little bit more functional. We start with the current time. So look at this. The current time is fetched twice from the computer clock. This is something I have seen in production code. Of course, in production code, these two places are not so close to each other. Often they are in a bigger distance. But this really happens. And there's a subtle bug because of this. We could test this. We would introduce a test clock in our unit tests, set a fixed time, test this method, everything is fine. But in reality, the computer clock is not at a fixed time between these two calls. So the day may switch over, and you get really subtle bugs that happen very, very rarely, and then it's hard to understand them, to find them. So what I want to do is, instead of fetching the current time from the computer clock, I would just pass it in. I changed, as an argument, I changed a little bit the method name, and now the methods in the time util, look at them. Day of week at, for example, we pass in a time zone and the current time. This is everything we need to compute the result, the day of the week. So the same is true for local time at. So these both functions or methods are now pure functions because of this little change. Okay. And what I want to do next is, I still have somehow a mix of I/O and pure functions. I would like to move up this the line loading the opening hours a bit to the top, to have the I/O besides each other, and maybe I could gain a bigger block of pure functions. The thing is, we do the filtering of opening hours in the database. And now I will do something, maybe you don't agree with me, but I assume that there's just a few records of opening hours per restaurant in the database. And anyway, if I have communication to the database, and anyway, a TCP packet must be passed over from the database to the app to my application, maybe all the opening hours for restaurant fit into this TCP packet, and I agree to the compromise that I will get all the opening hours for the restaurant and do the filtering in my application. Having this, I get a list of opening hours. After that, okay, I calculate the day of week like before, and in the third step, I do the filtering in my application. I have a list of opening hours, call the method find, and pass in the day of week to the predicate lambda. Wait. So now I have I/O at the top. I have pure functions at the bottom. Looks already a bit better. There's an interesting thing here. I think day of week is an example of caching something. Yeah, I assign the result of day of week add to a value, so effectively caching it. And in the lambda, in the find method, I just reuse it instead of recalculating it, because the day of week add is a pure function. I could also, or because both of them are pure functions, I could just inline the day of week into this lambda expression without changing anything. And this is, this is what functional programming gives us. It's also called referential transparency, that I can exchange values and expressions, values by expressions and vice versa, not changing anything in the outcome of my program. Of course, I changed something in the performance, because here in my version, I calculate day of week only once and reuse it. Okay, let's go on. Now we have a huge block of pure functions here at the bottom, and I will do this what I did in my earlier days as a programmer. I will separate them out I will compose them into a bigger pure functions, so that contains all four of them. And now this new pure functions takes 3 arguments: the restaurant, opening hours, and the moment of time. And this is enough to calculate if the restaurant is opened or not. This thing I'm going to test, and I really like defining my test cases in tables, because this allows me to add new test cases very easily. And on the left side, we have opening hours. The moment of time, we assume here that the time zone of the restaurant is fixed in my unit test. So on the left side, I have my columns for the input. On the right side, I have a column for the expected output. And I'm adding test cases like this. Yeah, I assume some opening hours, and let's say on Wednesday at 10 a.m., I assume that the restaurant is open. But on Wednesday at 10 p.m., it's outside the opening hours, so I expect it to be closed, and so on and so on and so on. So it's very easy to add new test cases. All the unit testing frameworks offer some capabilities of doing such table-driven tests. It's JUnit, Scala test, KO test, Kotlin test, Spock also has something inside. So that's quite easy. Short moment. So let's go on. We have one endpoint that to check, one endpoint for the customer to check if the restaurant is open. Now, the customer wants to order something. So we will implement another endpoint for ordering food. The question is, we want to reuse the logic of checking if the restaurant is open or not. Which of these both methods that are in orange, which one we use? The outer one or the inner one? Who's for the outer one? And who's for the inner one? Okay, I'm for the inner one too. Because if I would reuse the outer one, I have a mix of IO and a pure function here. So I would produce spaghetti code in my next endpoint because of this, because I would already mix it up by calling the outer method. Okay, so let's implement the endpoint for ordering food. It accepts some ordering data, moment of time, and it returns an order ID. So we go for restaurant to the database. I extended this a little bit that the code becomes shorter. I already check in this method if the restaurant data exists. So this is a new sign here. If it doesn't exist, the code will throw an exception. So this method produces exceptions and does IO. Get opening hours just loads opening hours, this IO. And after that, we validate if the restaurant is open at. Inside this method for validation, I will call the pure function that I separated out to another place, and I add some logic. I wrap it in, I use it in an if statement. If it's not open, I throw an exception. Now, we make up a new order. Everything is validated. And the thing here is, I mark this as a pure function because I don't want it to do IO in this place. This method contains business logic and is thought to just make up the order that I will persist afterwards. Save order will produce the order ID, generate the order ID, and this is clearly IO. So what you see is, I think this is a common use case like we implement things. The pure functions live in the middle. There's some IO at the beginning, then pure functions, and then some IO for persisting things. In our team, we place such methods on facades that are right behind endpoints. These facades have dependencies to readers and writers, doing loading all data upfront for running the use case. After that, we have pure functions in validators, and we called it service. Okay, you can call it like you want. And only after that, we will write things back to the database, or we will publish business domain events. The thing is, because the functions are pure, the validator and service, these are just simple objects having methods. Or maybe in Java I would have static methods. Nothing more. I don't need anything more. There's no dependencies to readers, writers, other maybe Spring Beans. And in fact, that's it. I think with this I could already live. This is much better than what I programmed 20 years ago. It's clear for everybody where to find the IO, where to find the pure functions. Okay, but you decide you can go further if you want to do functional programming. You could introduce nullable types in Kotlin, options, optionals, either, try, whatever makes your methods more predictable. You could start to work with futures. But this everything is not for doing IO in a pure way. With the futures, it somehow depends how they are implemented. But the standard futures in Scala do not allow for pure IO. For doing pure IO, you need another tool, and it's this. It's a simple class. I called it IO. It has a generic type parameter A, and it has a public constructor. a field which I called run, and this field has a reference to a function which produces me a value of type A. And the thing is, it's used like this. We divide the word in two spaces. We have the left side, where we instantiate this class IO, pass in some piece of code that does something, for example, loading data from the database. And when I have this description of this, I would call it of this effect doing IO, at some point at the end of the word, maybe for example in an endpoint, I will call run on it. I will execute it. So on the left side, you have this shiny world of functional programming where generating a description of an effect is the pure function, but running it is, yeah, like before, yeah. At some moment I have to run this IO. And there all the bad things can happen. And I give some syntactic sugar for the next examples. I will instantiate IO by just passing braces and some piece of code inside, okay? So my method order food on the facade, instead of returning an order ID, it will return an effect description that does nothing. Only when I run it, it will produce the order ID. And the thing is, on an endpoint, I want to return the order ID because otherwise there's no sense. So the endpoint, we call the facades method order food. This will return back a description of an effect, and on the endpoint we have the end of the word. It will call run and run all the IO, the bad things that can happen inside. Okay. So I want to rewrite my method now so that it just passes back an effect description which produces an order ID. And I can do this in the simplest case by just wrapping this everything into my IO class that I presented. I would be done. Yeah, so it's clear order food does IO, the bad things are happening. But on the readers and writers, the methods don't express this. They don't return a type IO that tells me, hey, bad things will happen when you run, when you call me, or when you run this, what I returned you back. So that's why I want to implement this IO on these reader and writer methods. So instead of returning a restaurant, I will return an effect description that will return me a restaurant when I call run on it. Okay, and and here I'm at the repository level, let's say, I just wrap it into an IO. And inside, let's assume Juke, I do some select where, whatever, fetch optional, throw an exception if the restaurant doesn't exist. And I have it, okay? So if I go back, I will have now 4 methods that return me an effect description. But next problem is I have to concatenate this with each other. I have to compose it. Having the restaurant, I want to go and load my opening hours. But the reader doesn't return a restaurant. The reader just returns an effect description. I don't have the restaurant at hand. So the question is, how can I come from an IO that returns me a restaurant to an IO that returns me a restaurant and opening hours? I have a tuple here inside. So what I first have to do, I have to run the first one. Of course I have to run it, otherwise there's no way to get hold to the value. After that, having this value, I can apply my logic on it. My piece of code doing something with the restaurant, using it for loading opening hours, for example. But I want to have an effect descriptor, so I must wrap it up again into this effect description. So now having returning this I/O with the restaurant and opening hours, it does nothing. It just instantiates me a new effect descriptor doing something more than the old one. Okay. And because I don't want to write this every time I do something with these I/Os, a lot of braces and parentheses, I pack the repeated parts into a helper method, which I add to the I/O class. So it's the call, I call it map. And this method map just takes this piece of code doing something with my restaurant, forgetting opening hours, and returns me a new effect description. And this method does the unpacking and the packing back into a new effect descriptor. There will be another method flat map. And here the piece of code I can pass in differs a bit because it doesn't return a value of this type B. It returns me a new effect descriptor. Okay, so I leave it up to you to maybe to implement it. And now, how can I, you see that in the first case, map is for pure functions. Yeah, I pass in a function that maps an A to a B. In the second case, I pass in a function that maps an A to a new effect descriptor. So the second one is for doing I/O. Of course, the compiler doesn't prevent me to use map, do something with an I/O under the hood and run it. Yeah. So this is a lot about conventions that you follow. Okay. So and in the end, combining this everything here would be here to call flat map on the first effect descriptor. And my function f is a piece of code that somehow returns opening hours. So when we go back to this code here, I will have to rewrite this to use flat maps. I can do this. Looks ugly. Because, yeah, unfortunately, flat map starts to, here it nests calls. And it's not nice, but I could return the first flat map restaurant and opening hours in a tuple and have it more sequentially. But I decided for this one because here I save some characters in my code. Now we do our stuff in Scala, and in Scala we get some syntactical sugar. I can rewrite this to a for comprehension. In Scala, the for comprehension is not a loop. This is a generator for all these maps and flat maps. And here I have the impression that it's a sequence. Under the hood, it's rewritten to this flat maps and maps in the nested style what I showed you. So this is the way how to do pure I/O in a pure way, in a functional way. And I think it was a lot of stuff. I want to summarize. We said that pure non-I/O functions are, of course, predictable, repeatable, refactoring safe, and functions that return effect descriptors, are they predictable? Of course, a little bit, because I seen that in the method signature that this method deals somehow with I/O, so this is predictable. But what exactly happens in this when I run it, this is not predictable at all. All strange things can happen there. Exceptions can be thrown, timeouts, whatever you can imagine. So somehow, are they repeatable? Methods that return effect descriptors, the instantiation is repeatable, of course. Passing in the same arguments to a method, you will get an equivalent effect description. And this is repeatable. But the world where you run it, of course, it's not repeatable because there's I/O happening under the hood. And next time you call it, it can do other things. But there's one thing about them, about these effect descriptors. They are refactoring safe, and this is something maybe you can try on your own, or we can discuss it later, maybe somewhere. They are refactoring safe, and they provide full referential transparency. So once you have your I/O code running, and you know that now it's okay, it behaves like it should. Refactoring your code with these I/O wrappers doesn't change anything in your programs. But pure functions have also some issues that you have to take care of. For example, if your context grows, we saw it when I composed the bigger pure function out of smaller ones, that my argument list was prolonged. And this is something we have to deal with in our daily life. Very often we solve it by using classes that group several arguments in the fields to have the method signatures still short. But there's another issue. For example, in our method is restaurant open at, we pass in restaurant and opening hours. Who tells you that the past and opening hours belong to this restaurant? Very often I have such thoughts when the arguments become more and more. Okay, I degraded performance somewhere else here because I loaded all the data up front. This is not only an issue in with the opening hours, but also for validation. We had the discussion in our team, should we load all data up front before doing validation? Because very often you can validate the first steps and just stop, throw an exception or stop the execution of your endpoint, and it's fast. But we agreed that most of the time the endpoints are running a happy path, so we will load everything up front. And yeah, this may be degrading performance when something goes wrong. And now the question is, are pure functions overkill for doing I/O? And here, with my experience, I would be fine having it in the first refactored version that I showed you, not using the I/O wrapper. Because if you don't have tool support for it, or maybe you come from reactive programming, so you are used with all these flat maps and maps, okay, then go with it, yeah. But if not, I would be fine just with a good old sequence and some conventions how to structure the code. Okay, and I think, yeah, that's it. This is what I wanted to show you, and I would like you to look at your code, maybe in a different way. Try to find these pure functions. Try to separate them out of this I/O stuff that happens somewhere else. Yeah, and I hope that your applications will be better in the future. I give you here's some literature that got me into functional programming. I really like the first one from John Yu, why functional programming matters, because he also said that the referential transparency aspect is not the most important one in functional programming. So thank you for your attention, and I'm open to your questions.